All right, Algebra 2, 4-8. Let's finish up Chapter 4 here, and we'll get ready for our semester exam. We're going to talk about complex numbers, and our essential question is, what are complex numbers? Complex numbers come from square roots of negative numbers, because you can't take the square root of a negative number. We've come up with this complex numbers, and what it is, it's a number whose square is -1. And what we mean by that is we denote I squared to equal -1. We just use that as a starting point. Just accept it that that's what it is. So if I squared is -1, then I equals the square root of -1. So how do we use that? Well, we start off using it by being able to simplify negative square roots by using the I. So if we get the square root of -18, you can't do that on your calculator. So what you do is we take that negative, and since I squared is equal to -1, I now write -18 as I squared times 18. Because based on this definition, I squared is equal to -1. So that's -1 times 18, -18. Then I can take the square root of the I squared, it's I. I can break down the 18 as 9 times 2, and I can take the square root of the 9, so I end up with 3i square root of 2. The whole idea of complex numbers is to get the negative out of the square root, which we've done. And we can tell it's a complex number or imaginary because of the I. Okay? The square root of -25, I'll rewrite the negative as an I squared. They're both perfect squares. I can take the square root out, I get 5i. Okay? So that's how we use it, to simplify and get rid of the negative inside a square root. What's an imaginary number? It's of the form a plus bi. Okay, as long as there's an I in it, it's an imaginary number. Okay, the a is the real part of it, we always write it first, and then the bi, the imaginary part, we write second. We can graph this by treating the x-axis as the real number and the y as the imaginary. So if we had 2 plus 3i, we would go 2 and up 3i. If it was a -2, we'd go to the left. If it was -3i, we'd go down. Okay. Pretty straightforward with that. There's another example or two in the book that can help you with that, but it's pretty straightforward there. Okay, absolute value of complex numbers. Okay, the absolute value of a complex number, just identify the a and the b, and it's the square root of a squared plus b squared. So if we had 3 minus 2i, the absolute value of it, a would be 3, -2 would be b. So it would be a squared plus b squared, 9 plus 4, the square root of 13. Okay? Again, there's an example on that in the book too, that's not bad. Adding, subtracting, multiplying complex numbers, it's just like combining like terms. Okay? Combine the i's with the i's, the reals with the reals. So if you had this right here, combine the 3 and the -2, you get 1, and the 5i plus 4i is 9i. When you get a minus, remember, that minus, you distribute it to both, so it becomes a plus, and then you change the sign of everything inside, so it becomes a +2 and a -4i. Combine like terms, 5 plus 2 is 7, -3i minus 4 more is -7i. You're going to multiply, you're going to distribute, just like you would if it was anything else. 3i times -5 is -15i, 3 times 2 is 6, and you get I times I is I squared. And remember, I squared is -1. So this is really 6 times -1, or a -6. And I kicked that out front to make it the real part, and minus my 15i. So I put it in that standard form of complex numbers. Here, you're going to FOIL. Remember, first, outers, inners, last. 4 times -1, -4. 4 times a -2, that's -8i. 3i times a -1 is -3i. And 3i times a -2i is a -6i squared. Remember, I squared is -1, so -6 times -1, that makes that equals a +6. So -4 plus 6 is 2. -8 minus 3 is -11i. Okay? Just like we would do if it was an x. Nothing new there. Division, that's a different story. You got to think about complex conjugates. And the complex conjugate is the same real number, but it's changed the sign on the middle of it. And the whole reason of that is, if you FOILed this, you'd end up getting a squared minus b squared, or a squared plus b squared. you get rid of the I, okay? And we don't want an I in our denominator, okay? So if you got a positive 3i, remember, whatever's in front of the I, you change the sign. You're going to multiply the top and the bottom by that, okay? This should kind of look familiar to you. You're going to distribute negative 3 and 9, negative 3 and 12. Now you got an I squared, so that becomes a plus 36 when you get rid of the I. The nice thing about the conjugate, you can see it here. 3 times a negative 3 is negative 9, I squared, and that again is negative 1. So you get a positive 9 down there. No more I in the denominator. The 9 goes into both of those, you get 4 minus 3i. Okay, so you multiply by that complex conjugate. Just change the sign on the imaginary part. If that was 1 plus 3i, then this would be 1 minus 3i, 1 minus 3i. Remember, that's just 1, so you're not changing the value of your fraction when you multiply by 1. Lastly, we want to solve for x. We're looking at quadratics here. Solve it just like we've been doing it. You've got just an x squared, so we talked about this in the last couple sections. Subtract the 32 over, divide the 2 out. Now you can see when you take the square root of both sides, you've got a negative. So just like I showed you simplifying the negative on that first board, change the minus to an I squared. You can take the square root of both, and now you're going to get plus or minus 4i. Okay? Because now you're actually solving for x, so when you do that, you're going to get that plus or minus. Okay? If you get a trinomial, factor just like we've been factoring trinomials. Factors of 3 that add up to 2. Are there any? No, 1 and 3, it doesn't work, right? So what do you do when you can't factor it? You guessed it, quadratic formula. Whoops. So x is going to equal negative b, so that's negative 2, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay? That's going to give me negative 2 plus or minus the square root 4 minus 4 times 3 is 12 all over 2. Negative 2 plus or minus the square root 4 minus 12 is negative 8 over 2. There's your complex. Can't leave a negative inside there, so I'm going to rewrite that as, remember this right here is the same as 8 times I squared. I'll just go ahead and write it all out. So that's negative 2 plus or minus. Now I can square root the I squared. 8 is 4 times 2. That's a perfect square. So I'm going to get negative 2 plus or minus. Square root of I squared is I. The square root of 4 is 2. So I'm going to get 2i square root of 2 all over 2. And 2 goes into both of those. There's my final answer. Okay. This example might be in the book also. Can't remember if I took it out of the book or one of the problems we were doing. But when you can't factor it, okay, use the quadratic. If you can factor it, but chances are with what we're doing now, you won't be able to factor, so you have to do the quadratic, and that's how you get the I in there. We want to get rid of that negative. Okay? So it's just quadratic formula, which we did in the last section. All right, hopefully that's been helpful. That's complex numbers. Simplifying them, add, subtract, multiply, and divide, and solving. Okay? We'll look at more of this tomorrow in class and some application. All right, we'll see you then. Bye.